All right, so very briefly, let me just discuss a little bit about who HDIAC is and what we do. So we're a Department of Defense sponsored organization. For those of you who don't know, we administratively report to the Defense Technical Information Center, but organizationally we're situated underneath the Assistant Secretary of Defense for Research and Engineering. And this position actually reflects the dual mission that we have. We support research and development efforts within the Department of Defense, and we also serve as an activity that collects and stores and disseminates information, primarily to support those R&D efforts by helping to reduce duplicity and redundancy within the government. So the big question is, why the flu, why now, right? Why are we having this webinar today? So as I mentioned earlier, this has just been a pretty bad season. Some of you on the call today are from the CDC, so you have been knee deep in this for months. Others have, played a role in public health for a long time. So those of us who have worked in healthcare, public health know how bad the flu can be, and this has been a pretty bad year. The flu can cause pandemic illness as well as seasonal. So that is something of concern when we talk about economic and national security issues. We're going to talk more about that impact towards the end of the webinar. When you look at military operations overall, disease is just a really old enemy of the military, going all the way back to the Civil War, to some of the things that the surgeons had to deal with on the battlefields, to the days of Walter Reed fighting yellow fever in Cuba, and some of the other illnesses that we still battle today, Ebola, smallpox, things of that nature. This unfortunately also happens to be 100 years since one of the worst pandemics in the history of the world, the 1918 Spanish flu. And we're going to talk a little bit about that, the impacts that we still feel today. And it's also a good time to kind of reflect back and see what's changed, what hasn't changed, what are some of the sticking points that we still need to work through. And that brings up this final point, why the flu now? Well, we still have these persistent challenges. We've got vaccine efficacy and production, things that we can talk about. We can talk about logistics, whether that's within the United States or other global operations that DoD has to be concerned with, getting vaccines to rather remote areas. And then also some of the improvements that can still be made in diagnostics. So what we're going to do is we're going to play a brief animation here. And what you're looking at is the geographic spread of the flu in the United States for this current season, so 2017 to 2018. So the way that we measure this is we look at the weeks of the year. So typically we start measuring things in October, and you can see the map has this very nice kind of pleasant green color, indicating very minimal flu activity. And as the season has progressed, we get into the winter, and we're going to get into 2018 here in a few seconds. You can begin to see the colors of the map turning from the green to the yellow to the orange and finally red. This just indicates the number of cases that have been reported. In this particular map, we're looking at influenza-like illness, what's been reported in terms of symptoms that are very similar to the flu. Some of these cases turn out to be the flu, and some of these turn out to be other things. But this is a way that CDC can measure kind of the spread and the reporting of these different cases. This is quite interesting because we'll look at some other DoD statistics here shortly, and you can kind of see some of these correlates. So hopefully that just gives you a little bit of an indication of what we've been dealing with. And, those numbers in particular reflect what CDC has collected for the United States. Those do have some military members and their dependents, of course. And this impacts DoD operations in a few ways, because we're not just looking at private citizens, but also these are people that have to go to work, that work at the Pentagon, that work at the CDC. So nobody is necessarily immune to the flu, and that's a concern that we will talk about later. So here's some more information from the CDC. We're just talking about laboratory confirmed cases of influenza hospitalizations. So you can see the red line indicates the 2017-2018 season, and we're already ahead of where we have been in previous seasons. So if you had a suspicion that this was a bad season for flu admissions, you were right. Another thing that's been an issue this year has been the vaccine effectiveness. We're currently at 36%, which when you look at the numbers, it's not the worst season for vaccine efficacy in history, but it definitely hasn't been the greatest. That's for a number of different reasons, I think. And one of them is that we've tended to see a predominance in H3N2 this year. So vaccines aren't always great in guarding against that particular type of flu. And we'll talk more about different types of flu in a little bit and why that makes a difference. One thing of note that even though the vaccine efficacy has been fairly low, it has been shown that this particular year, the vaccines have helped to reduce your risk of dying from the flu. So even if you got the vaccine and still got sick, you were less likely to die from the flu than if you didn't get the vaccine at all. And so finally, just one last graphic here showing all the different positive flu tests by subtype. And we'll get into a little bit more of what these mean later. But again, the predominance of the type A strain over type B, and in particular, the H3N2 strain that we have seen. All right, so we're going to show a little animation here, just illustrating the kind of global breadth of operations that DoD operates. And this is important for a few different reasons. First of all, just the logistical challenge. DoD has bases all over the world, offices all over the world. So imagine trying to get vaccines, treatment options such as Tamiflu to these places, ensuring that service members are protected. It's mandatory for all active duty and reserve personnel to have the flu shot. DoD does a fantastic job of knowing where people are, but just getting the vaccines to them so that they can be vaccinated is a challenge. And then also, you know, we kind of take this for granted, but living here in the United States, our flu season typically is in the winter months, right? October into the early spring. And so we tend to think that once we're out of the woods, the rest of the world kind of follows suit, but we don't really think about where DoD operates. That's not necessarily true, right? Because when it's winter here, it's summer in the southern hemisphere, and of course that flip-flops. So when we're out of the woods, other areas of the world may be dealing with the flu. And then also when you look at tropical regions, the flu can actually happen anytime during the year. So DoD always has to be prepared to battle a flare-up of influenza. All right, so we're going to look at some DoD numbers here real quick, just to kind of put this into perspective. So what you're looking at are some maps from the Armed Forces Health Surveillance Branch, and they collect a lot of great information. They are kind of the epidemiological branch of DoD, if you will. There's a lot of information that they collect and also share with CDC. But if you think of DoD operations and how this is all divided up, we're looking at combatant commands, right? So for example, the United States falls within the Northern Command, so NORTHCOM. So these numbers are going to be very similar to the CDC maps I showed you earlier. When you look to the right and also the figure on the bottom, we've got EUCOM and we've got PACOM, so European Command and Pacific Command. So this is just a representation of the flu activity that's been reported by DoD among service members and other dependents and beneficiaries in these areas. So the numbers, they've been, as we would expect, a little bit worse in the United States and NORTHCOM. We've got somewhere, I'd say, around 3,000 cases, confirmed cases of the flu. When you look at Europe, it's quite less. It's around 100 cases or so. And then PACOM is probably around close to 400 cases. So DoD tracks the flu no matter where they are, which I think is a really interesting thing to consider. All right, so as we move ahead, we've got a little bit of an introduction on why we're actually talking about the flu, how DoD fits into this, and the kind of interconnectedness between all these different agencies. And we're going to talk more about how this all fits together, and I think you'll see how it unfolds as we go through. But let's start with the basics. So what exactly is the flu? So for those of you who don't know, it's a respiratory illness caused by the influenza virus. We'll talk more about what that virus looks like and how it works in a little bit. But if you've ever had the flu or know somebody who has, you probably are familiar with these symptoms: fever, chills, cough, muscle aches, and headaches. The flu just puts you down for a few days. And if you think about the impact in terms of the fighting force and security and things like that, if you have the flu, you're not going to really feel like fighting, right? So it can be quite an incapacitating sort of thing. It's spread by droplets during a sneeze or cough. The virus actually catches a ride on these droplets and is inhaled by somebody else. There's been some new research that has just come out, I believe this week or last week, that shows that actually the virus could be spread just through coughing alone, not necessarily riding on these droplets. So that's something to kind of think about as we go forward into looking into prevention and the epidemiology of how this illness is spread. The incubation period, or the time from when you actually become infected to when symptoms begin to show up, is an average of 2 days. And as I mentioned earlier, the flu is of particular interest because not only do we have these seasonal flare-ups, but it is capable of causing pandemic illness. So in terms of a pandemic, right, we're talking about things that can cause an inflation in the average number of cases and deaths far beyond what we would normally see in an average season. All right, so here's a little bit more about the flu. If you look on the right, you'll see what the actual structure of the flu virus looks like. You have those little coils on the inside, that's the genetic material. And then surrounding on the outside, you have these proteins. So hemagglutinin and neuraminidase. And these become very important when you're looking at categorizing the type of flu that exists. And we're going to talk more about how we do vaccines, right? And so this becomes a factor. This also is a factor in the types of flu that exist. So let's talk about those real quick. So we got 4 different types of the flu. And this actually matters because some of these are a lot more contagious than others, right? So influenza A is probably one of the more common ones. It's also one that we worry about the most because it's the only type that's been known to cause pandemics. And this is classified in terms of those hemagglutinin and the neuraminidase particles. So we hear things like H1N1, H3N2, that's what we're talking about. The other common type of flu is influenza B, and these are broken into lineages. The 2 common strains of B this year have come from the Yamagata and the Victoria lineage. When we get into influenza C, it's relatively rare, and when it does occur in humans, it causes pretty mild symptoms. So we typically don't worry about it too much, as it really isn't much of a public health threat. And then finally, there is an influenza D virus. These are primarily known to only affect cattle. We haven't had any cases in humans. So on the public health front, not really much of a concern in terms of people, maybe something that agriculture or veterinarians may be concerned about, but we typically don't worry about this too much when we deal with human health. So let's talk about the epidemiology real quick. So the numbers of cases and deaths that we see in an average season. So these are some numbers that have been pulled from a variety of different sources that you can see the sources on the bottom. So in terms of epidemiology, we talk about surveillance, right? And there's a few ways we can do that. We can look at what we call syndromic surveillance. So we're looking at symptoms that would align with what the flu would have. So people go to their doctor, to the ER, they report a cough, a fever, body aches, things like that. That may be indicative of the flu. And in fact, we call these collections of symptoms influenza-like illnesses, right? Sometimes they turn out to be the flu and sometimes they don't. But the way that these get reported, one way is through CDC. They actively manage this through the Epidemiology and Prevention branch and the Influenza Division. And then when we get into DoD, what I mentioned earlier, the Armed Forces Health Surveillance Branch, they also monitor these cases and these numbers, and these things get counted. And so I'll draw your attention to the hospitalizations. All of these numbers are annual, except for the DoD one. That's the current number there. So we've got 37 service members that have been hospitalized to the flu and 171 other beneficiaries. A lot of this information also comes from the laboratory-based influenza surveillance program operated by DoD. There's also Medical Countermeasures Directorate, which looks at vaccination policy, looks at what DoD is doing in terms of ensuring that personnel and beneficiaries are safe, that they're healthy and fit for. So all of these things kind of work together, and this interplay between DoD and CDC will come more into play at the end when we talk about some of the national security issues. So let's talk about some of these pandemics here real quick. And I think this is the most interesting thing about the flu, is that it can cause quite a devastating illness. So we're going to talk a little bit more about the 1918 Spanish flu in the next slide. So let's talk about a more recent pandemic, 2009 swine flu outbreak. So these are some of the numbers that have been reported from CDC. And you can see that this particular strain was the H1N1 flu. And the acronym there, the PDM9, just indicates that it was responsible for the 2009 pandemic. So we have about almost 61 million cases, 274,000 hospitalizations, and 12,000 deaths. So this has been a relatively significant pandemic. And if those of you who are around in public health during this, you'll know all of the signs that went up at the airports, the measures that were taken to try to prevent the spread of the flu. I was at another organization at the time, and I know there was a lot of work that we did with the CDC to ensure that risk communication was effective and messaging and things like that. So this was a rather significant outbreak. But let's go a little further back in history and talk about one of the worst public health crises of all time. And I think that this is really important to talk about because in some ways a lot has changed in 100 years and in some ways a lot hasn't. So what you're looking at here are some actual pictures from primarily the U.S. Army. And starting on the left, we have soldiers at Fort Riley, Kansas. And so this is a war that was set up to take care of all of these people that have fallen ill from the flu. One theory of how the pandemic spread was that it actually started at Fort Riley, and as American soldiers were shipping off to Europe, in response to World War I, that they were bringing the flu with them. There's another theory that it actually started in France, and so if you look at the second picture there, this is American Expeditionary Force Hospital that was set up in France. So these are Army soldiers being treated for the flu. So you can imagine the world is at war. Everything's devastated, right? People don't really have the resources to necessarily handle something like this. So that just kind of fed into the spread of this entire pandemic. And finally, if you look at the right, this looks like somebody's back porch, but it's actually an open air ward at Walter Reed. So this is something that was set up to treat soldiers that were returning from Europe that had fallen ill with the flu. So talk about some numbers here real quick, and then we'll move on to some of the more current things that we want to discuss in terms of diagnostics and treatment and so forth. So altogether, it's estimated somewhere between 20 and 40 million deaths worldwide in the 1918 pandemic. Some estimates actually on the upper end take that up to 100 million deaths. If that were actually true, we're talking about the number of deaths from the 1918 pandemic possibly exceeding the total number of fatalities from World War I and World War II combined. So quite a significant event in human history. When you look at the United States, 20% of the population infected and possibly 500,000 to 675,000 deaths. So quite significant events. And we're going to talk about why this still matters and some of the things that we're doing to ensure that we don't have something like this ever again. All right, so let's move forward. Now that we know a little bit about the flu, let's actually talk about how we determine whether or not somebody has the flu. So this is a decision tree put out by CDC, and I believe this is pretty universal. DoD and other agencies would follow something very similar to this. So somebody walks in and you assess whether or not they have signs of the flu, and then you kind of go from there, right? And so we can estimate who may have the flu based off of these symptoms. The flu is not a reportable illness. The only thing that's reportable about the flu is pediatric deaths. But otherwise, we have to estimate the number of adults that we think are infected. But one of the ways that we can actually confirm that somebody has the flu is through laboratory testing. So these are the currently available types of tests that exist on the market. The gold standard is the PCR and the viral culture. So these have very high sensitivities. However, they do take a little bit of time to run. Some of the newer molecular-based tests can actually be done maybe in an hour and a half or so. But these have to be done in a hospital laboratory. So you're talking about being in a fixed location. Some of the other tests that are quite popular, the rapid influenza test. So this is a test, if anybody's ever performed this or had this done, you take a styrofoam tip applicator, you put it in somebody's nostril and his nostril, and then there's a little test. You can put the swab in a little test tube and you swirl it around and some stuff, and in about 15 minutes it turns colors and you can know somebody has the flu. So there's a few limitations to this. The sensitivity is relatively low, so about 50 to 70% or so. The good news is that the specificity is high, so we're pretty sure that we're not having too many false positives or false negatives, but we may be diagnosing people with the flu that don't necessarily have the flu, right? Or vice versa. So we have to be careful with this test. Another limitation is that these particular tests still very much laboratory based, and so we're going to talk about some of the research and development that's been occurring to move these out into what we call point of care testing. And so any of you who are interested in finding out a little bit more about these tests in detail and kind of where we're heading, this is a very good review article. Like I said, this presentation will be available for download at the end, so you can have access to this. But I recommend this as a good read to kind of get you up to speed. All right, so let's talk about going forward. So what's in the pipeline in terms of flu diagnostics? So we're still very much interested in the rapid flu test, right? So one of the things that the research is focusing on is how to make the sensitivities better. In terms of the PCR and the viral cultures, right, we know that that's the gold standard. So there's been some research looking at how we make the PCR test faster. Some of that's being done with some new emerging technologies, looking at microelectrical mechanical systems and nanotechnology-based systems that can more rapidly diagnose these particular illnesses. So these are some things to watch out for. One other area of research is looking at actually understanding which viruses, which strains of the influenza virus may be sensitive to which types of drugs like Tamiflu. So that's kind of a whole different set of diagnostic tests that are being developed. So it's very, very interesting to see how a lot of this is going to play out. But I think one of the biggest trends that we have seen is the evolution of these paper-based assays. So these are actually relatively inexpensive tests that have been developed, and here's a number of them that have been reported on in peer-reviewed literature and also in clinical trials. And so basically what this is this is a paper-based sensor test that operates very similar to how a home pregnancy test would work. They're relatively cheap. It's only about $1 or $2 per test versus something like PCR that's going to be several $100s per test. These things can be transported into the field. They can be used in remote locations. So this is that transition towards the point of care testing that I had mentioned earlier. One of the challenges with these particular tests is that they are qualitative, right? So it just tells you, do you have the flu, yes or no? We can't quantify the copies of the virus that we could do with something like PCR or with a viral culture, right? So we don't necessarily know how infected you are. We just know that you have the flu or you don't. One thing I will mention in terms of trying to create a paper-based test that may actually be able to perform PCR, that's something that's kind of been a holy grail. And so DARPA has supported some research into that area. So for right now, that's still a little bit of a moonshot, but that's something that we're heading to. So creating a relatively inexpensive paper-based assay that can perform PCR. All right, so once we know that you have the flu, what do we do about it, right? So what we've got right now is we have basically antiviral treatment, right? So there's medications that exist on the market that can be given to somebody. And what these do is these interfere with the way that the virus actually attaches to the host cell so that the genetic material can't be introduced into the cell. The viruses can't reproduce themselves, right? They need a host. So if you can interfere with that mechanism, then eventually the virus will die and you can reduce its ability to replicate. So you can reduce the amount of time that somebody may have the infection in their body. So we've got two different classes here of these antiviral medications that have been used for the flu. The first two belong to a class of drugs known as adamantines. And these are not currently recommended by CDC to use. I just put these up there so that you can see these were a class of drugs at one time that were used, but you can see that they're quite ineffective against influenza A and have no effect against influenza B viruses. The others belong to a class as the neuraminidase inhibitors. Remember, neuraminidase is one of those proteins that's on the flu virus. And so the first one, some of you may recognize as Tamiflu. The second one, perimavir, that's a relatively new one. But all three of these are recommended for use by CDC, and they seem to be quite effective against both influenza A and influenza B. So I know some of you on the phone do represent private industry, and that's good because you fit into this whole ecosystem very well. We'll talk a little bit more about how this all works later, but DoD doesn't have any production facilities, doesn't create any of its own vaccines or any of its own medications for the flu, right? So they rely very much on private industry. A lot of that work is often funded by other areas of the government. So National Institutes of Health, in particular, National Institute of Allergy and Infectious Disease, has funded a lot of vaccine development and also treatment modalities for the flu. So these are two things that are in the pipeline. So the first one has also been supported with BARDA, Biomedical Advanced Research and Development Authority. So they also assist a lot with pandemic responses and chem bio incidents and things like that. The second one is the development of a new class using monoclonal antibodies. So we see this a lot in other types of treatments, whether it's cancer, autoimmune diseases, or something like that. So this is a whole new set of research looking at using monoclonal antibodies in terms of how they may be effective against fighting the flu. So these are still things that are developing, but some things to look at on the horizon. All right, so finally, we're going to talk about the prevention, and then we'll get into how DoD and CDC and everybody works together to keep the United States safe and minimize the chances of pandemics spreading, and if they do, what we do about it. But let's talk about how you can not get the flu. So typically what we think about is vaccination. And so we've got a graphic here that shows how the CDC works on an annual basis to ensure that the viruses are being identified and how that selection works into creating a vaccine. It takes about 6 months from when a specific virus is identified and when you grow that and you turn that into a vaccine and look at production. So when you think about where we currently are, we're still, possibly just past the peak of this current flu season. And the next flu season won't begin for another, 7-8 months, something like that. But we've already begun production on the vaccine. We're already thinking towards next year. So this is a round-the-clock effort. So there's two different things that CDC looks at, right? So we do an antigenic characterization, look at all these different types of the flu that are circulating, do different types of tests to see how effective they may be against different types of, how the vaccine may be effective against different types of viruses. The other thing that happens is a genome sequencing and genetic characterization. The flu can mutate quite rapidly. It's actually a very unique type of virus that is very adaptable and flexible. So CDC will look at the genetic characterization of the virus and compare that to what exists in other vaccines. And even if you have the same sort of strain like an H1N1, you may have some slightly different genetics that may alter the effectiveness of a vaccine. So that's good to know so that we can tweak formulations and get that information into the hands of people who need to know for vaccine production. So let's talk a little bit about different types of vaccines. So two of the most common types, right, we have a trivalent vaccine, which means we've got 3 different types of the virus that goes into the vaccine. Typically, should be 2 A's and a B, so an H1N1 and H3N2, and then we've got a B virus. And so these are those strains that were picked for this year. And then we also have a quadrivalent vaccine, which just means that we have 4 different types of the flu. So we added another B strain, so typically you have 2 A's and 2 B's. And we'll talk a little bit more about how these work and why these are important in a second. The main difference, other than one has 3 and one has 4, is probably cost and maybe complexity of development. So I think this is a good slide to kind of show some of the complexities, and you may not be able to figure this out right away, but you can look at all of the different flu vaccines that have been produced for the 2017-2018 season. And why this is important is you can see there's only a handful of companies that produce the vaccine, right? So this is really important because, as I mentioned earlier, DoD doesn't produce its own vaccines, right? So we have to reach out to private industry and purchase these vaccines. So for this year, you'll see that the yellow lines indicate the vaccines that DoD purchased, and these are all quadrivalent vaccines. And so not only do we have a limited number of companies that can actually produce the vaccines, but for 2017-18, we actually estimated is going to be 119 million doses produced, right? So it's not like we produce billions of doses. So 119 million seems like a lot, but when you think about the world population, you think about how long the flu season lasts, it really isn't that much. One of the other challenges is that if there is a pandemic, how are you going to ramp up production to produce more vaccines, more doses, right? So that's always a challenge. I know CDC and DoD have worked together looking into this issue. DoD has worked with other pharmaceutical companies looking at how they may be able to do this more effectively. And finally, something I mentioned earlier, but just the logistics, right? Vaccines typically can't get warm, so how do you keep these cold as you ship them? How do you make sure that you're ordering enough and you're staging them in areas where they can actually be reached? So these pose a lot of challenges. And then something else I want to talk about, it ties into that transmission map that we showed earlier and kind of how DoD is divided up in these different combatant commands. DoD operates all around the world, and so looking at how public health operates around the world, it's a little bit different than how the United States views it. So not everybody may get vaccines, and you also have to think about different types of strains of the flu and where they exist. So one thing, many of you in public health will understand this, we look at a principle called herd immunity. And so basically, we know not everybody is going to get the vaccine. We hope that we can vaccinate enough people so that we kind of create this little protective barrier so that if somebody isn't vaccinated and they get the flu, they're not going to necessarily transmit it to somebody else who has a vaccine, right? They're going to have some protection. And eventually, if you have enough people who get the vaccine, even if you have some people who don't, those people are kind of going to be protected in this little barrier. So this becomes important as you're operating on a global footprint. All right, so let's talk a little bit about research and development in terms of vaccine. There's some things here that I think are quite cool. So I listed just what I thought were some of the most important and kind of the ones that are probably going to be at the top of everybody's list in the next year or so. So the first one, many of you have probably heard, is universal vaccine, right? Just creating a vaccine that can be effective against all strains of the flu. So instead of having a trivalent or a quadrivalent, we have one vaccine that can, handle all of the different strains. So if you look at figure 1 up there, this is a prototype that was developed by NIH, and this is a particular vaccine that they've developed, and the yellow particles are actually hemagglutinin. And so the way that this is designed is that this particular vaccine molecule can adhere to any surface of the flu virus, right? So it's quite an interesting thing. And the other thing I want to talk about is what we call these microneedle patches. So if you look at figure 1 and figure 2, these are basically the same thing, just slightly different designs, but these are small patches that are placed on the skin. And if you look at, I think figure 2 towards the bottom in that row, you'll see these little kind of gray spiky things. So these are microneedles. And the vaccine is actually placed inside these needles, and this patch, it's probably about the size of a circular Band-Aid. It's put on the skin, and once it's on the skin, these little needles begin to dissolve, and the vaccine infiltrates into the skin, and eventually will provide some immunity. So these are just 2 ways to possibly do that. If you want to read more about it, there's some information there in the sources. And then finally, there's been some research looking at creating, whether it's a trivalent or quadrivalent vaccine, but something that would be a single dose but last much longer, right? Vaccine efficiency is only going to last for so long, so this might be a way to kind of extend that. One other thing I want to mention, going back to the universal vaccine, DoD has actually supported some research in this area. So back in October of 2017, they awarded FluGen a contract to do some testing looking at how a universal vaccine might fare. So this is something that definitely has been at the top of DoD's priority list for R&D. All right, so we are getting to the end here. We're going to start wrapping some things up. I'll just take a minute to kind of reflect on where we've been. So we had an introduction to the flu, why it's such an important thing to talk about, how deadly it can be, how much it can actually affect health. We've also talked about some diagnostics, talked about where some of that research and development is going, talked about treatment, and we talked about prevention. One thing I mentioned about prevention, we typically think about vaccines, but there's a whole other aspect of this, right? The non-medical countermeasures. So just good hygiene, washing your hands. If you're sick, don't go to work, stay away from people. It's one of the worst things you could do, right? Everybody wants to power through and go to work when they're sick, but then they end up infecting everybody. So good public health, right? Just isolation is a very good way of dealing with the flu. And we see this a lot, right? One of the major non-medical countermeasures is shutting down schools, shutting down workplaces. So these are ways that are also used to prevent the spread of the flu instead of just looking at vaccines. They're supposed to be practiced in conjunction with each other. All right, so let's move ahead and talk about how all this ties together, right? So when you look at the flu, it's not just public health implications, but we're also looking at economic and productivity consequences, right? So the cost of the flu is actually quite high. So you look at an estimate of medical expenses, we're talking about just with seasonal flu, $10 billion a year, and then somewhere around $16 billion in lost earnings. So this is quite consequential when you're talking about the economic developments of a country. We're talking about a nation that's trying to get out of recession, right? So if you have a large epidemic timed at the wrong time, it can actually cause some significant economic impacts as well as productivity and health impacts. And then worldwide, you look at some of the pan-flu numbers here. We're talking about some significant losses of GDP. So this could be quite an economic hardship. So it's another reason beyond just minimizing fatalities, but also minimizing economic consequences. And so another aspect that we don't always think about is the security aspect, right? So if a whole bunch of people get the flu, it weakens the fighting force, it weakens the nation, it weakens our ability to protect our borders. So this is another reason why we want to minimize the spread of the flu, because once people get the flu, they're not effective at their jobs, and we have to worry about how that may affect our national security and our homeland defense. So this is just some bullets from the National Intelligence Council. This is, 18 years old, but I think it really still has some important things to think about. Some of the things I mentioned about, its impact on military personnel deployed across the world. You think about some other things, immigration issues. The United States has forces that work in Europe, that work in other areas where you have a lot of migrants. So things that you need to think about, what's being transmitted from one area of the world to another and how that might pass through a DoD installation and some of the consequences that may be afforded there. And let's talk a little bit about all these different roles of these different agencies and how they work together. So the first one I want to talk about is CDC and Health and Human Services, right? So CDC obviously is one of the largest public health providers in the United States, right? So they're looking at the epidemiology, they're making recommendations on how you treat certain diseases. And so they have a lot of very good, robust information on responding to a pandemic. In this particular case, a very good framework for influenza. So these are the different steps here in this framework that CDC recommends if there is a pandemic. And that also ties into the Health and Human Services. So they also have a whole other branch that deals with disaster response and health impacts and health disasters and things like that. So these are things to consider during a pandemic. Pretty much everything that we touched on, right? Surveillance and epidemiology, so you can actually understand how many cases, what people are being exposed to. We look at the diagnostic, who actually has the flu, what type of flu, looking at how people are being treated, are they being hospitalized, so things like that. So all of these tie in together as things that are important because you have to understand the impact on the health system, on security, and other areas of critical infrastructure. And so, DoD, as I mentioned, doesn't necessarily operate in a vacuum. So if there is a pandemic, DoD has a very large role to play. And in fact, DoD and CDC worked hand in hand together. And there's a liaison from DoD to CDC. So they very much coordinate between one another. And if there is a pandemic, DoD has, some very important roles to play. So there's obviously the information sharing where we talk about the epidemiology and statistics. There's also some opportunities to help with logistics, getting resources and personnel to areas where they may be needed. DoD has a fantastic logistics network with the Defense Logistics Agency, as we saw in the Puerto Rico Hurricane Maria response. So that oftentimes is enacted to assist in facilitating the transfer of resources when they're needed. DoD can also play a role in enforcing a quarantine if that's something that is needed. So there are many ways that DoD fits into this whole larger role of the pandemic. So I think when we started and we talked about influenza and DoD, and we kind of started with the flu and, intersprinkled DoD into this. Hopefully you can see now how this really kind of wraps up together, that DoD is not just a microcosm, that they play a significant role in terms of fighting the flu in general. And so just one more thing I want to talk about before we wrap some things up, and this is an area of particular interest to me, and I know some of you on the phone have dealt with this area, but talking about biological weapons, developing virulent strains of viruses and things like that. So these are some bullet points from a number of studies that have been done over the past few years, looking at different types of biotechnology and synthetic biology techniques that have actually characterized the flu, made it more virulent, made it easier to transfer. These studies have all been couched as ways to understand the transmission of the flu, to understand how it genetically mutates. And the argument is that if we can understand this, then we can be better prepared to mitigate that, right? We can take that knowledge and we might be able to lessen the virulence of the flu. We may be able to lessen its ability to transfer. On the flip side of that, because these are dual-use technologies, obviously if this information gets into the hands of the wrong people, they could potentially use this to create, new types of bioweapons, right? And something to think about, it's not necessarily just about killing people, right? We don't really necessarily care if a whole bunch of people die from the flu. Sometimes the intent is just to incapacitate an adversary, right? So if you imagine a whole bunch of people getting sick from the flu, they're not going to be able to do their jobs. We're not going to have war fighters who can be effective. So these are some things to keep in mind as we go forward, as the technology increases in terms of its technological prowess, right? A lot of these things are becoming more possible by all kinds of different groups, not necessarily just state-sponsored or large states anymore. All right, so congratulations to all of you who are still on. You've made it to the end. So we're going to do a brief wrap-up here, and I'll talk a little bit about some of the services that we offer, and then we'll take some time for questions. So when we look forward and talk about what's next, as I mentioned earlier, the next flu season is just around the corner, right? We've already started preparing vaccines for next year. We've begun characterizing what types of strains are in circulation, so the cycle never ends. And of course, there's always research and development being done and looking at some of these new techniques and diagnostics and vaccine development and things like that. Another thing that I think is interesting, WHO just reported something here, that there is a new type of flu virus that was just detected, the first case of this new type of avian flu H7N4 in a human. So that's something to keep in mind that may be on the horizon. And finally, one other thing I want to talk about is some work being done by DARPA. This is a program that has just been released, and I believe they finally made the announcement of funding partners. But this is a program that aims to take some genetic material of these viruses, and this isn't necessarily specific to the flu, although the flu would be one of these that would be of interest, but looking at a pathogen, understanding the genetics of that pathogen, how that can be used to create what we call a transient immunity, and at least buy some time so that we could develop some sort of medical countermeasure, whether that be a vaccine or whether that be some type of medication. And all of this would be done within 60 days. So that's where DARPA is heading, and that's probably honestly the future of, I'd say, vaccine development and medical countermeasures. So before we take questions, I'd be remiss if I didn't talk about some of the services that we offer. So for those of you who don't know, we offer a technical inquiry service. We can provide up to 4 free hours of analytical services on a topic as long as it fits within one of our 8 focus areas. So if you have any questions about the flu, feel free to chat us here and we'll answer those before we wrap up. But also if you have some more in-depth questions, this is a great way to get those questions to us and we can provide a deeper level of analysis. I also have my contact information up here so we can always talk offline later. But this is a great way to ask a question and get some information and let us utilize that huge repository that we have in order to better serve our federal clients. And one of the things that we have is a core analysis task. This is a pre-computed, pre-awarded vehicle that we have. We can help facilitate projects within the federal government. So any agency can come to us with a task that needs to be completed and we can assist you in that task. We can reach out to our partners and utilize our technical expertise within the center here. These projects need to be completed within 12 months and have a cap of $500,000. But the good thing about this is that work can begin in as little as 6 to 8 weeks after a statement of work has been approved. So we can get started pretty rapidly and have a quick turnaround time so we can meet some deadlines that you may have. Before I take questions, I just want to thank the HDIAC staff who has supported this webinar. They don't always get all the glory. My face and bios everywhere, but I can't do it without everybody here. So I want to thank Fatina Casey, Amanda Andrews, Tim Gould, David McCarville, and Jamie Glover, everybody who's played a role in putting this webinar together and supporting me in getting all this information together. So thank you, everybody. With that, I think we'll open it up to take some questions. Oh, we do have a question here. All right, so Joe asked a really good question. Joe lived in Houston for a bit, so of course he would ask about the Gulf Coast. I don't necessarily know if the spread follows a specific pattern every year. That's a good question. I can look that up and get back to you. I doubt it, but it is a good question. I'll look into it. So while we're waiting for a couple questions to come in here, I see some people typing. I just want to kind of reflect a little on the list of people who signed up. It looked like we had a nice representation of different government agencies and some private industry. So I think that really reflects the ecosystem that I mentioned earlier, how DoD shares resources with CDC, FDA, NIH, private industry, how this all kind of flows together. CDC characterizes different strains of the flu, makes recommendations for vaccines, private industry, goes into production mode, creates those vaccines. DoD purchases that from these companies. Agencies like NIH and even others like DARPA and DITRA are sometimes involved in supporting research and development of vaccines and diagnostics and things like that. So all of this really kind of works together. That's why it's so difficult to just talk about DoD and the flu without talking about kind of the corollary, right? Talk about the flu and how DoD fits into all of this. So we're still going to stay on here. We've got, let's see, Dr. Hansen. I can get back to you. I think the paper where they talked about the microneedle, I think had all the information in it. I can send you that paper if you want. And I think that may help, and we can always talk later. All right, thank you very much, Dr. Hansen. Appreciate that. So I'm still going to stay on for a few more minutes. Hopefully, we've got some others who will finish typing in their questions. Thanks, Scott. We appreciate that. Like I said before, it takes a village. So I want to thank everybody. We we worked well together to put this on for everyone. So I'm glad you enjoyed it. All right, looks like there's some information on upcoming conference. So thank you. We'll write that down and look into that. It looks quite interesting. So we'll stay on a few more minutes. Yeah, thank you. I'd appreciate that. If anybody wants to reach out to me at any time, we'll have my contact information up. Send an email, give me a call. I love talking about this stuff. My background's in healthcare and public health, but I don't really get to talk about the flu very often, so this has been refreshing. Yes, at the end of the presentation, when we wrap things up here, we'll have this presentation available for download, and then tomorrow we'll actually have the whole webcast available on social media. So if you want to listen to this again and watch it, we'll have that available for you. How do you download it? Fatina is doing stuff, and I believe it's available right there. So if you look at the bottom right of your screen, HDIAC publication, HDIAC webinar, Influenza the DoD, that PDF will be this presentation for today. So something I should have mentioned earlier, this has been a really easy presentation to put together because there's so much information on the flu, but it's also been a very difficult presentation to put together because there's so much information on the flu. So we put what we thought would be the most relevant and pertinent, and I like to talk a lot and not necessarily have everything on a slide, so I wanted to tell the story with the backdrops of statistics and things like that. But there's a lot more information, so if you're interested in other sources, feel free to reach out to me. We can talk about stuff. There's other things I can send you. I'm probably a little bit better to look at research and development things and not necessarily epidemiology and biostatistics, but I'll be happy to answer any of those questions if you have questions about that. But if you want to know more about where the field is going, what sorts of R&D is being invested, things like that, I'll be happy to talk to you. All right, so just want to remind everybody, we will have this on our website tomorrow on our social media, and we have a whole bunch of other resources available. So feel free to go to the HDIAC website, www.hdIAC.org. We also have a quarterly journal that we publish, so we have lots of different articles in there that fit within our focus areas. And if any of you on the phone are interested in being an author for us, we're always open to accepting abstracts and papers, and we do have a very robust subject matter expert network. So if you're interested in participating in our SME network, you can find more information about that on our website. You can sign up. If you have more questions, you can give me a call or an email, and I'll talk to you about that. But all those resources are available on our website. We also have past webinars and other presentations there as well. We have a short video series that we produce called Tech Talks. So we have a library of those with various topics. We've done some others in the past talking about infectious disease and DoD and things like that. So if you want to look back through the archives, you may find some other interesting information. We have our next journal is going to be published in March. So we've got some new things coming out. There's going to be an article in there about synthetic biology in terms of how it can be used as a weapon of mass destruction. So we talk about some of the flu things that I mentioned with the horizontal gene transfer. So lots of stuff going on. Feel free to go to the website at any time, contact me, contact any of our other staff, and we'll be happy to assist you. If you have any questions about technical inquiries or the core analysis tasks, there's information that can be downloaded as well here at the end of the webinar, and it's also available on our website. All right, so it doesn't look like anybody has any other questions. I want to thank everybody for joining today, and remind you that we do have another webinar coming up in March. We'll be talking about wearable technology and how DoD is using that, and we'll have a guest presenter from Sandia National Labs. So I want to thank everyone for joining us today, and we will catch you hopefully next month.